Welcome back to our final video in the QM2 notes, which is a series on factoring polynomials. So up to this point, we have looked at factoring through the use of a greatest common factor. We have looked at factoring by grouping. We have done factoring of quadratic trinomials, and we've looked at some shortcuts for quadratic trinomials with the difference of two perfect squares, and also some relationships between squaring any binomial. Today we are going to finish off with our final factoring technique that we are going to focus on in this lesson, and we're going to take a look at the sum or difference of two perfect cubes. So we did this difference of two perfect squares. Now we're doing the sum or difference of two perfect cubes. So I'm going to give you a rule, just a pattern that we can follow, and then we're going to verify this is correct, and then we're going to use it. So let's say we have a cubed plus b cubed, some value that is a, where a and b are real numbers that are being cubed and added together. This can be factored into a plus b times a squared minus ab plus b squared. Now I can verify this to be true by doing some distribution here. So you don't necessarily have to do this if you don't want to, but if I distributed the a, I would get a cubed minus a squared b plus b cubed. And then if I distributed the b, I would get a squared b, a positive a squared b. I'm going to line up those like terms. Then I would get minus ab squared. So I would have a squared b minus a squared ab squared plus b cubed. Oh, we made a different mistake here. Let's back this up. Let's do the distribution again. Sorry. Let's try that again. So if I distribute the a times a is a cubed. And then I would have a times ab, which is a squared b. And then I would have a times b squared, which is a b squared. There we go. Then if I distribute my b value, I'd have b times a squared, which is positive a squared b. Then I would have b times negative ab, which is negative a b squared. And then I would have b times b squared, which is a positive or b cubed. And so this would simplify down to a cubed plus b cubed. So we can see that this rule is going to work. So this gives us a way to factor. We did the multiplication here, but this gives us a way to factor a sum of two cubes. Anytime you have two integers or two expressions that are being cubed and added together. We also have a way to factor a difference of two cubed. A cubed minus b cubed is going to be equal to a similar expression, but the signs are going to be a little bit different. The quantity a minus b times a squared plus ab plus b squared. So notice that in the first binomial it's a and b. In the second binomial it's a squared, ab, b squared. The signs, when we compare the signs to the original expression, the signs are the same. So when it was positive, it matches up with positive. When it's negative, it matches up with negative. Then the sides are opposites. When it's positive, it goes to negative. When it's negative, it goes to positive. And then the last one is always positive. So what I have here is a little acronym to help us remember the formula here. It's a and b, then a squared, ab, then b squared, and then SOAP for the signs. The same sign followed by the opposite side, followed by always being positive. So let's see how that works with an equation. So let's look at 5a. It says factor each of the cubic polynomials. A cubic function is a polynomial, or a cubic is a polynomial of degree 3. So we solved quadratics, where it's degree 2. Cubic is degree 3, meaning the highest exponent is a 3. So factor each of the cubic, x cubed, polynomials. So what we can see here is basically we try to want to find out, like when we did with the difference of two squares, what's being cubed to give us these values. So what's being cubed to give us x cubed? That one should be pretty easy. X is being cubed. What's being cubed to give us 125? Well, if you know that it's 5, that's great. If you don't, we can help use the calculator here. So we could do math, and then we could do the cubed root of 125. So 5 is being cubed. So what does this give us? This gives us our A and our B in this expression right there. So what I do is I fill in the numbers first. So it's A, which is going to be our X. Then there's a space. Then there's B, which is our 5. Then it's A squared, so X squared. Then there's a space for a sign, A times B, so 5 times X. And then there's a space, and then it's B squared, which is going to be 25. And so now I can fill in my signs. So my signs would be the same as the original sign, positive, opposite of the original sign, negative, and then the third one is always positive. So my answer here is going to end up being x, or the factored version is x plus 5 times x squared minus 5x minus 25. Now you might want to try to factor a little bit past there. You might want to try to factor that x squared minus 5x plus 25, and we're going to find that we actually cannot factor this any further. So this is fully simplified here. So this is a sum of two perfect cubes, and how we would factor that. B is the difference of two perfect cubes. So again, we want to start off by trying to figure out what's being cubed here. So obviously, again, x is being cubed to give me x cubed. 3 is being cubed to give me 27. And again, the way we can check that is to do math down to the fourth option is the cubed root of 27. So my A is x, my B is 3. I'm going to use this expression now. So again, it is in parentheses A and B, then A squared, so x squared, then A times B, 3 times x, and then B squared. 3 squared would be 9. My signs are the same, so because this is negative, I'm going to stay negative. The opposite, I'm going to change it to positive, and then always positive. And so this is the factored version of what we saw above. Now, if you kind of get the pattern, see if you can pause the video and complete problem C. So in problem C, this one's a little bit more complicated. We have to figure out what's being cubed to give me 64x cubed. So first, what cubed gives me 64? If you said 4, then you'd be correct. So 4x, if you cube it, is 64x cubed. 1 is being cubed to just give me 1. So my A in this case is going to be 4. My B is going to be 1. So I can fill in for the sum of two cubes. A is 4x. B is 1. A squared would be 4x squared, so 16x squared. You square the 4 and the x. A times B would be 4x times 1. And then 1 squared would just be 1. Now my signs are the same, so positive. The opposite, negative, always positive. And there we have the factored version here of part C. Let's go ahead and take a look at number 5. Number 5 looks pretty complicated the way that it's written. But what we may notice here right off the bat is we have a GCF. We have a GCF. Both of these have a 5 that can divide the coefficients, and both of them have an n. So what I'm going to do is factor out the 5 in. I'm actually going to go ahead and factor out a negative as well. So I'm going to factor out a negative 5 in. You wouldn't necessarily need to factor out the negative, but it's just going to arrange my terms a little bit in a little nicer of a manner. So If I factor out 5n, that leaves me with m cubed, sorry, negative 5n, that leaves me with m cubed and 8n cubed. So now this concept stays the same. I need to figure out what is being cubed to give me the terms here inside these parentheses. So I'm going to leave this 5n, this negative 5n alone in front of the equation. So I've got the negative 5n. Now what's being cubed to give me m cubed? If you said m, you'd be correct. What's being cubed to give me 8n cubed? Should be 2n. So now we're going to continue to leave that negative 5n out in front. We have the sum of two cubes here. So m and 2n. Then m squared, m times 2n, which would be 2mn or 2nm, and then 2n quantity squared, which would be 4n squared. Now I fill in my signs, the same, which is positive, opposite, which is negative, and always positive. And here I have the factored version of D. E is very similar, so see if you can pause the video and complete E. Hopefully you had a chance there to do E. Now let's go ahead and take a look. So the first thing that I want to do here is find my GCF. Both of these terms are divisible by 2x, so my GCF could be 2x. What that leaves me with is 125x cubed plus 64. So now I've got a cubed value here, so I think this is the sum of two cubes. And if I think that, I might test for that. So what cubed gives me 125? 5. What cubed gives me x cubed? Just x. What number cubed gives me 64? That would be 4. So this is the sum of two cubes. So my a value is 5x, my b value is 4. So I'm still keeping that 2x out in front. Now I have a, which is 5x, b, which is 4, a squared, so squaring 5x would result in 25x squared, a times b, so multiplying a, or 5x and 4, would result in 20x, and then b squared, which is 16 squared, would result in 4 squared would result in 16. Now I fill in my signs the same, positive, opposite, which would be negative, and then always positive. And there I have the factored version using the sum and difference of two cubes. So the sum and difference of two cubes is a factoring technique that is useful for us. On some occasions, it's not frequently used in Algebra 2. We'll see it on occasion. It's good to practice it and to know that and to have that tool in your tool belt. But if you get the concepts prior to that, those are the ones we're going to focus on as we progress into quadratic functions, our next unit. This is a good place to end. Thank you guys for tuning in, and I'll see you soon.